I just thought I'd say a few sort of setup words before we get going. I think it was about 5 years ago we had a meeting in this room, and we invited a social scientist from the UK, and his name was Robert Doubleday. Does anyone know Rob? No. He was embedded, I'll use the term lightly, in the Cambridge University nanotech lab. And he came and spent about an hour talking about his experience in the lab. And my impression then was this could never work. This was just a disaster. This was sort of something out of C.P. Snow's two-culture problem. And it struck me as both. It was tantalizing and masochistic on his part. But he was a participant observer. He was a muse. He was a provocateur. He was all of those things. But it was, at another level, quite fascinating. And I couldn't take my eyes off of him for an hour as he explained his time in the lab. And I think part of it had to do with three things. I think one is most of you have been sort of involved in this whole discussion about upstream governance. How do we actually take the consideration of environmental, legal, social, ethical issues and move them further upstream in the R&D process? Anticipatory governance, real-time technology assessment. There's a whole bunch of ways of framing this. But I think at some level we don't quite know how to do that yet. So this was an interesting attempt to do that. I think at another level, it represented what some people here call, Mike Gorman included, trading zones. He was creating a kind of trading zone where people from different, essentially, disciplines could actually come together and hopefully have a fruitful and meaningful discussion. The third thing that intrigued us, and we couldn't say much about it then, was we felt that this obviously was a model that could be highly transferable. He was focused on nanotechnology, but why couldn't we do this for synthetic biology, cognitive neuroscience? There's no particular reason that it had to just be a nano exercise. So at that point in time, we saw this as quite interesting, but kind of somewhat untested. And I think what you're going to see over the next 2 days is we've run a significant number of tests in terms of trying to embed people into laboratories. And this 2-day exercise is an attempt to kind of get our arms around what's happened. What are these experiences like? What are important things or lessons learned? What would we do different if we can do it or continue this exercise? So I think what I'm going to do is I'll turn it over to Eric, and Eric can kind of go through the flow of the next 2 days. And we'll start with sort of the case studies. Eric?
Thanks, Dave. Got some slides here that we'll see if they open. Let me just begin by thanking two Daves, Dave Rajewski and his research staff here at the Woodrow Wilson Center for hosting us at this wonderful venue and providing support and an audience and a webcast. So thank you very much. And I want to acknowledge your new program, Science and Technology Innovation Project. And the other Dave is Dave Gustin, who directs the Center for Nanotechnology in Society, whose untiring support of the STIR project and its ideas continue to be highly effective in getting the ideas out there and shaping the vision for the future. So this is the fourth project workshop, and it's the first one that we've opened up, as it were, to people that are beyond the immediate cohort of what I call integrated scholars, social scientists and humanists who have spent time in laboratories. And what we're trying to do is bring together a number of people in order to achieve a couple basic things that I hope will make sense to you. The first is to present some examples of what I'm calling socio-technical collaborations in the laboratory. At this point, we've conducted well over 20 such collaborations, and we're fortunate enough to have, in the morning session today and tomorrow, 8 different co-presentations on what these collaborations look like, some of the things that might have happened. So we'll have 4 plenaries. Each plenary will have 2 presentations, and each presentation will have 2 speakers, one social scientist and one natural scientist. And I'm going to ask Brenda to help keep time, since we're going to try to limit each collaborative presentation to 20 minutes maximum and still leave time, 20 minutes at the end, for the moderator to say something about the interest of their organization in such collaborations, and then to take a couple questions from the audience. Those will be the morning plenaries. Then in the afternoon, we'll hear a couple keynote addresses, and we'll bridge C.P. Snow's two cultures. We're hearing both from an engineer and from a social scientist on successive days. And we want to think about some of the ways in which responsible innovation is interpreted and might relate to these types of socio-technical collaborations. And finally, in the breakout sessions and the activities that follow those, we want to envision what it might be to extend these activities. On the one hand, we've come a long way since Rob Doubleday's single study in the UK and my single study in Boulder, Colorado, and we've now got over 40 labs or thereabout participating in these types of activities. But that, of course, is a drop in the bucket. So hopefully we can actually energize ourselves and envision what it might look like to scale up. So why are we talking about integrations? Why are we talking about socio-technical collaborations? One easy answer to that is because policymakers around the world are focused on these things. And I'll give you an example. In 2003, the U.S. Congress passed and President Bush signed the 21st Century Nanotechnology Research and Development Act. This authorized the National Nanotechnology Initiative, and essentially blessed what was already there. But it did a couple of things. It generated more report obligations, and it also said we want to consider societal and ethical and legal considerations during the development of nanotechnology. That's not really anything new. We had done that already for the Human Genome Project, okay, giving birth to what's known as the ELSI studies, which have migrated from the U.S. to Europe and back again. What's new about the legislation is that it calls for integration of considerations, research on societal considerations being integrated with research and development. Okay, this is new, and if you read the House Science Committee report that accompanies the legislation, the staff is very specific in terms of why this integration is meant to occur. It's meant to influence the direction of ongoing R&D. One House staffer at the time said that the ideal outcome is to integrate societal concerns directly into the technology development process. Well, not only is this new, it's also, as it were, unproven territory. Okay, as the legislation itself says or implies, we don't know if this is possible. Okay, so on some level, the STIR project and various socio-technical collaborations around the world, that some of which we'll hear about today and tomorrow, are meant to probe the extent to which these things are possible, as well as their feasibility and their utility. And it's not just the US, Canada, the European Union, the UK, the Netherlands, Norway, Belgium, all have similar policies for integration. Some are more specific, some are less specific, but they call for this type of radical integration that is meant to change the nature of science and engineering, how it's done, for the sake of the broader social investments that are being made in it. So my suggestion is that we need to figure out how these things are possible and what their utility is so that we can design good ones and not bad ones. It would be very easy to imagine a routinized policy that develops where we're just checking boxes, or worse, we're somehow being counterproductive in trying to integrate social concerns into science and engineering. So how do we think about these mandates for integration? Where do they fit in terms of the governance of science? Let me suggest a highly simplistic scheme that is somewhat useful for thinking about these things. We can think of the governance of science as happening in three basic stages: authorizing research, implementing those authorizations, and then adopting the outcomes. All right. And if we want to simplify the language, we can use the stream metaphor. So upstream authorizations, policy decisions, what research to conduct, how much to spend on it, why to do it. That's before the research in the laboratory gets underway. Downstream decisions, how to regulate science and technology in society, that's presumably after the laboratory has done its work. Okay? So the midstream is where I see these integration policy mandates as starting to operate. They're opening up, as it were, the processes of science and engineering for integration of broader considerations. But if you look at the various mechanisms, and I've just taken the U.S. as an example here, we don't have any formal mechanisms for influencing the direction of ongoing research, which again, to invoke the language of the House Science Committee, commenting on the U.S. federal legislation. So again, uncharted territory, okay? So the STIR project, STIR stands for Socio-Technical Integration Research, and the idea is we want to try to conduct this integration in the form of collaborations and then study it so we can say what's possible and what's the possible value of these collaborations. What can they do? What can't they do? What kind of work do we need to do to get through to them? How do we compare results across types of laboratories, different fields of science and engineering, different national cultures, different political cultures? So the project formally consists of 10 integration scholars. You can see listed on the left-hand column. Each row here represents one of these scholars, his or her discipline, the two cities in which he or she operates, and the laboratory or field of science that characterizes both laboratories that she's operating in and comparing. As I said before, we've since it's been expanded, so there's a number of satellite groups and whatnot that have joined the STIR project and are essentially applying the same integration tools or methods, which I want to quickly take you through so you have some inkling of what it is that these people have done in the labs that I've encourage them not to talk about, right? There's a lot of jargon coming your way, and I apologize for it, but it should be fairly painless and quick. This is probably the worst of it, midstream modulation. This is a framework that we use for thinking about how the midstream could be subtly tweaked, modulated, incrementally changed, not from the top down, but from the inside out, from the bottom up, where the scientists and engineers who work in labs are the ones who are making the changes at their own discretion, okay? But where the social scientists who are in the labs observing and feeding back their observations are able to catalyze or structure the possibility of changes, okay? So this basically says that de facto modulation happens all the time, which research is an interplay of human, social, and material elements. Seems pretty simple, but it's actually a Herculean effort to move from de facto modulation to what we call reflexive modulation, which is simply getting practitioners who are involved in research to recognize that they're actually making decisions, that they're not just following steps, whether these are logical steps or authoritarian steps that come from on high. It's really interesting. It's a very simple move, and I think this is endemic not just of science and engineering, but any highly routinized, structured, capitalized endeavor in the modern world, that if you're in the middle of things, it's very hard to think about how you fit into a larger socio-technical system. So integration work is largely just trying to move from de facto modulation to reflexive modulation. Okay, having practitioners and decision makers recognize that they're involved in practices and decisions. Then we hypothesize that that subtle shift of awareness then sets the basis for what we call deliberate modulation, intentional changes. Changes to practice, changes to laboratory policy, changes to educational structures, whatever is possible and interesting and useful then can simply become more effective. So I want to stress that the integration scholars don't come into the laboratory and tell the laboratory how to change its practices. That would be counterproductive. And the integration scholars don't really have the knowledge necessarily to do that. It's more a collaborative effort where the integration scholar talks to scientists about the scientific decisions that the scientists are making and just cycles through that again and again until it creates a shift in awareness, and then we just watch the research as it develops and look for correlations. We also have a very simple protocol for basic questions. What are you doing? Why? How else could you do it? What might happen? We spiral through this on a regular basis. This can be done in 20 minutes. Sometimes these discussions last over an hour. They can be done while someone is conducting an experiment. As a matter of fact, we're told time and time again by the laboratory researchers that it's actually useful to them to think about these questions while they're conducting their research. And the idea for this was that upstream public engagement is important for setting upstream policy questions, but it's not necessarily going to be effective at changing the midstream. Right? If you take scientists out of the lab and you talk to them about research priorities, when they go back to the laboratory, it doesn't necessarily have an impact on their practices. If we're interested in modulating the midstream, if we're interested in opening up science, making it more reflexive, catalyzing changes from within, then I think we need to be operating from a situated standpoint. We need to be, it has to be hands-on. And of course, the social scientists get a tremendous amount of knowledge and insight in actually not just watching science, but doing science with scientists. The protocol is meant to really just expand the decision spaces that people are operating in. On the one hand, expanding the perception of relevant values and concerns that are operative in the research. These could be things that were promised in the proposal. These could be things that the Research Council is looking for. These could be strategies that the laboratory has for growing itself. These could be social concerns that are being debated in the newspapers, as well as expanding the perception of available choices for moving forward. So it just gives more choices and a sort of broader array of voices and considerations that can be matched to those choices as we move forward. If we rearrange the protocol, we can, use this image, which just simply suggests that you start off by talking about science, you end up talking about the public policy mandates that fund a lot of that science. And by the way, we're not just in private in academic laboratories. We've got a couple private labs too, but this is mostly talking about public money. So what happens? Let me just give you three sort of categories of outcomes. One, we can get rid of the language of reflexive modulation and just talk about learning. Probably the most frequent pattern we've seen alludes to what I've already mentioned, and that is that try it sometime. Talk to some laboratory researchers and ask them what kinds of decisions they make. Chances are you're going to be told we don't make decisions. Especially if you're called a social scientist and you've just walked into the laboratory and you've invaded their space, and they're worried about all sorts of things that you might find out about how they do what they do and what sorts of public controversies you might be about to spark. Okay, so on some level it's a knee-jerk reaction. On another level, I think it really makes sense based in terms of how highly structured scientific practices are and how routinized they are. And how easy it is to sort of insert yourself into the practice of research and see yourself as not really making decisions. After a couple of days, a couple of weeks, we tend to be told by these same people, yeah, I guess I do make decisions, okay? And that's actually a point at which now it's sort of a breakthrough. Now we can start talking differently about the research that they're doing. Changes in practice are interesting. They give us a sense that these conversations, this feedback, the collaborative process actually can show up and then be assessed in terms of its value. On the one hand, changes in practice, changes in research, the type of research that's done, the questions that are being asked, the ideas that come up, experimental setups can change, health and safety procedures can change, the way people talk about what they do, and even the policies that the laboratory has, whether for health and safety, patient outreach, or training, can change. These are important because they're indicators that we're doing something that has impact. However, I want to stress that probably what's most important is the learning that goes on, that is more invisible, because this has more of a long-term potential to change institutions. Just an example of the changes in practice, as Stuart Lindsay, who will be joining us soon, and I wrote in a letter that was published in Nature, Reflections on Responsible Innovation among a lab group generated novel ideas for antenna structures and nanoparticle synthesis. So the idea is that we're really trying to attend both to sort of the broader social considerations and the creativity and integrity and productivity of research. And then the last category I want to suggest are residual effects. Now, this is more of an unstable category because not all the studies have residual effects, and they're not all the same. But it's certainly an area of interest. And in this case that I've got up here, this was from the pilot study that I conducted in Roop Mahajan's laboratory, and we'll hear from Roop later today. 18 months after the study was concluded, written about, published, I came back to the laboratory and found out that this person's dissertation in the abstract, right, 50 words, 2 of those words, 6 of those words are a direct result of conversations that he and I had and changes that he made in his research project. And there's no way I could have known enough to tell him how to do things differently. Okay, so it was, but he probably wouldn't have been catalyzed to do this had I not been there asking him questions and feeding back observations. So it was really a nice collaborative change, and it was lasting. So what are my points here? I'm going to suggest that socio-technical collaborations that occur in real time in the laboratory, in which both members of the team are involved and learning and bringing things to the table, are possible. We can do them. We've got proofs of concept. Okay, that's an important point because the U.S. legislation raises the question whether they're possible or not. Secondly, they're valuable. They're valuable for at least two reasons, and this brings up the notion of responsible innovation. We can enhance scientific creativity so we can advance innovation with them. We can also enhance social responsiveness of the innovation. So that's the responsible side of responsible innovation. So these two functions, scientific creativity and its social responsiveness, have historically been seen as at odds with one another. But what's interesting from a number of the case studies is that we can actually find evidence that they're mutually reinforcing one another. And finally, I will claim that we need to scale these activities up. It's easy to do. It's necessary if we want to avoid bad policies, bad programs, counterproductive activities, okay, which assume from the outset that collaboration is not possible. And it's important for members of the public whose monies are being used to fund research and who sometimes have questions about science and technology and society. And finally, it's important for training a new breed of experts, integrated experts in the natural and engineering sciences as well as the social and human sciences. I'm going to leave you with that and shift, unless there are any pressing questions or remarks that people have, to our first plenary. Sound good to you, Dave?
Yeah, I think just in terms of, let me just do logistics. This is essentially where we'll spend most of our time. Breakout sessions will get you to the breakouts in terms of where they're going to be in the building. You should have access to an open network if you need to log in. If anybody has any problems doing that, let us know. Also like to thank Eleanor Powell's in the back, who did a lot of the heavy lifting with Eric in terms of setting up the logistics. And then Todd Kukin also in the back. Todd, can you raise your hand so people know who you are? If you have any questions, issues, just hunt us down or ask us, and we'll try to deal with them as we go through the day. Lunch, we'll be serving lunch probably right around noontime when we do the plenaries. So I hope you have a great 2 days. I'll be kind of in and out because the most important thing I want to hear is how to scale this up. I'm glad to help you work on that. But yeah, why don't we do the plenaries?
And we should probably mention, so that you don't get confused, there's two agendas circulating. There's one that says tentative agenda. You want to shred that one. That's the one that's found in these little black folders. If instead you picked up separately on the same table the one that says agenda, then you won't be misled throughout the next 2 days in terms of timing. All right, well, while our first plenary assembles itself in the front, let me just say a couple brief words. Was there a comment? Okay. Okay, well, dinner tonight I think starts at 5, not 6, so that's important. So this plenary will be moderated by Dr. Pierre Mulien, who is President and CEO of Genome Canada. We're fortunate to have him here. We're both sort of blessed and cursed with the AAAS meeting. We're blessed because a lot of people are in town and can attend. At the same time, a lot of people are prepared for information overload, so I think this room isn't quite as filled as it otherwise would have been. And we're going to hear from Shannon Conley, who's a PhD student in political science at Arizona State University, and her collaborator in the laboratory, Courtney Hanna, who's a PhD candidate in medical genetics at the University of British Columbia.
All right, thank you everyone. As Eric said, my name is Shannon Conley. I'm in political science as my discipline, and I'm from Arizona State University. And I really just want to thank my collaborator, Courtney Hanna, for being able to make it out here today after a lot of struggles on the plane and getting here at like midnight last night. So thank you, Courtney, really appreciate it. But I'm just going to dive right into talking about my laboratory engagement study with Courtney's laboratory in Vancouver, British Columbia. The title of my talk is Collaboration and Engagement. The focus is on the Vancouver site. Although I did do 2 studies, the other one was in Oxford, and you know, if it comes up, I'll be alluding to that throughout. So first off, what are we going to explore today? So I want to just kind of talk about the why. So how do I see STIR situated in the context of the big picture of the governance of science? Why is STIR important? The where and the who. So who did I collaborate with? What did they do? What did Courtney do? What does her lab do? And what happened? What were the outcomes of me being embedded in her laboratory for 3 months? And how does this relate back to the big picture of governance of science? How does it relate to the why? And I'm going to go through 4 different examples illustrating the price paid for integration. So what does it take on both of our parts as collaborators to engage with each other, really? What does it take? What is the price that we have to pay? And then I'll conclude with just some final thoughts and dialogue between me and Courtney on collaboration. So the importance of STIR. Why am I doing STIR? Why is it important to me? And you know, how do I justify my engagement in this? It really starts with a quotation from Langdon Winner. He engages in the philosophy of science, and the quotation that's really important to me comes from his book, The Whale and the Reactor. And really briefly, here's the quote. He says, "Within the technical realm, we repeatedly enter into a series of social contracts, the terms of which are revealed only after the signing." So what I like to think when I'm thinking about this quote and how I kind of conceptualize it is, you know, take, for example, an example from our daily lives. I'm sure at least half the people in this room are on Facebook, right? I am. Did I know when I had first signed up to Facebook that the pictures that were posted could have an impact on my job, that they could have an impact on my work life, my personal life, and that private corporations could potentially mine my personal information for data? That was only revealed after the fact that I signed up, years later. And so Winner implies that these contracts are kind of immutable. You know, once we're in them, we can't really get out of them. We're kind of stuck with the terms that were dealt. So I argue essentially that, you know, I do like this concept of the contract, but at the same time, it is flexible. You know, we're not stuck. We can talk, we can engage, we can change things. So the idea is to open up those contracts, and that's where the idea of anticipatory governance comes in, opening up tracks for clear negotiation of these issues. The question is, how are we going to do it? What's happening right now? How are people dialoguing about this stuff, and how can we do it better? That's what anticipatory governance asks. So how does STIR fit into all of this? Well, STIR is a systematic, intentional effort to open up the laboratory as a venue for negotiation of those terms of the contract, if you'll continue with the metaphor with me, for negotiation and renegotiation. So with STIR, I see this project as engaging with laboratories as the terms are actually being written, the terms of these broad contracts between, you know, individuals in society, between institutions, between stakeholders, so as the terms are being written. I see the laboratory as a potential venue for tapping into scientists' own imaginaries of the future. What kind of world do they want to live in, and how do they think about it? And how can I engage with them to kind of bring those imaginations to light? And so STIR taps into that through dialogue, engagement, and embeddedness. Is there potential to tap into those imaginations and act on them? And to consider them in the day-to-day laboratory life, within material practices, within laboratory policies, as Eric was alluding to. So I really see STIR as an experiment in exploring the mutability of the terms of that contract. So how flexible is it really? And can we, you know, through this project, actually explore what type of flexibility is there? So kind of coming from the conceptual and down to kind of the more of the nitty-gritty, how are we going to do this? Here are just some really briefly integration tools. So daily embeddedness in the laboratory, on my part, structured interactions, weekly one-on-one interviews with our collaborators, unstructured interactions, so just casual conversation and dialogue at the laboratory bench, within the lab, outside the lab, getting coffee, and exhibiting persistence, a desire to understand scientists' worlds despite potential resistance, and that's what I call the price of integration, on both of our parts. And also probing for diverse ways of engagement and understanding through kind of unconventional means. And in my case, it's actually engaging in hands-on practices, doing experiments, working side by side with my collaborators, pipetting, doing the daily monotonous things, and engaging with them that way. So the laboratory that I worked with focuses on reproductive genetics. So why reproductive genetics? Why is it important? So to me, it seemed like this would be one of the natural places to go if we're thinking in terms of these broad socio-technical contracts, political institutions, how we kind of configure our lives around technologies. These technologies are pervasive tools used at both the individual and societal level, essentially to control the nature of life itself. They impact how people choose to lead their lives in relation to each other, broader society, and in relation to future generations. And the most basic and fundamental of human institutions are built around reproduction. I mean, think of marriage. So the laboratory, as distant as it might sometimes appear from this, is intimately connected with these systems. And so that's why I decided to go the route of engaging with a reproductive genetics laboratory. So just kind of taking another step into kind of the more of the nitty-gritty from the conceptual, my first field site is, like I said, a reproductive genetics laboratory in Vancouver, British Columbia. It's Courtney's laboratory. They engage in novel prenatal diagnosis techniques. They study the genetic causes of premature infertility. They focus on chromosomal abnormalities, epigenetic changes, and disorders that are linked to the placenta. There's a female PI. At the time that I was there were 2 PhD students and a number of other folks in the lab. And there were 3 males in the lab at the time, and the other 6 were female. And there's just a picture of the lab. So I just want to talk about an initial encounter that I had. This is when I'm gonna be going through my examples, and what does it take for collaboration? And these examples to me are instances of kind of showing what does it take on both sides of the coin from myself and my collaborators to get collaboration to work. So I'm just going to really briefly talk about my first meeting with the PI of the laboratory, in which I sat down with her, told her about the project, and she said, well, it's like we're talking 2 different languages. I don't really understand where you're coming from. And so there was kind of this initial, you're talking one language, I'm talking the other. We're not connecting. I don't see how we're going to make this work. And then another thing that she said was that ultimately, social science is soft science. It's good because you can point to it as evidence. It's fun, but not something I would want to do again. And she was referencing back to a survey that she did once. So not something that she would want to do again. So it's the idea that there's these 2 cultures going on, and they're not overlapping. And then that was my first meeting with the PI, and then I had the first meeting with the laboratory shortly after, where the PI and a couple of the other researchers were talking about the differences between American and Canadian genetics conferences. And I'm coming in there as, I'm from America, and, the majority of the folks in the lab are Canadian. And they were talking about how American genetics conferences, they're so big, they're loud, whereas, Canadian genetics conferences, people are so much friendlier, they're nicer. Why would I ever want to go to an American genetics conference again? So here I am, just kind of thinking like, okay, here's like multiple levels of like, there's a difference in our cultures. How are we going to move forward and start talking? How are we going to overcome these language barriers? So kind of in the same vein of language, just the idea of how are we going to start talking the same language. There's just a really brief, kind of funny example where I was in the lab for about 2 weeks. I heard this term SNP being thrown around. What's a SNP? I don't know what a SNP is. I was thinking like SNIP, like scissors, so I didn't want to embarrass myself by asking because, I was a new person in the lab and I should have just came out and said it. But I decided to do some research on my own and see if I could figure out what a SNP was, without just so I could understand what was going on in the lab. And so I was Googling SNP, SNIP. Nothing was coming up in relation to genetics. And when Google fails, you know that you're in trouble. So I took that next step, and through my structured and unstructured interactions with the folks in the laboratory, I just came out and asked them, and it came out in our conversations, what is a SNP? Well, no, Shannon, you don't spell it SNIP. You're never going to figure out what it is that way. It's SNP. It stands for single nucleotide polymorphism, which is, essentially when a letter in the code gets switched for another letter. But here I was just, thinking like, okay, SNP. So this is an example of the laboratory serving as a venue for translation. And, I could have learned that in a class, but would I have learned it in the same intense way that I did in the laboratory? Probably not. That learning came about as part of those intense daily interactions. And it's also an example of, it's representative of my complete lack of knowledge of genetics and my initial trial by fire education in that realm. So as I was in the laboratory, there was kind of a slow but steady progression of engagement. Me stepping into my collaborators' world and them stepping into mine. And so the next example is one of bench-side engagement. So my collaborator, Courtney in this case, actually stepping into my world, engaging with me and, speaking my language, essentially. She and I engaged with each other on what responsible innovation means to her. We talked about the limits and boundaries of responsible genetic research as she was at the lab bench pipetting day in and day out. We would share articles, thoughts, advice, and insights, and she actually gave me advice for my research, people that she thought would be, useful for me to talk to in terms of kind of further conceptualizing what responsible innovation means. But she was really taking a step into my world and engaging with what is responsible innovation. And so there's that sense of give and take. We're both getting out of our comfort zones. We're both kind of getting out of our bubbles and going back and forth. So at that point, I'm at the bench. I'm engaging with my collaborators. We're talking about, various things, from their material practices to, the things that I'm interested in terms of, social science research. But really, this next example is kind of taking it to the next level in terms of our interactions. I was asked by my collaborators to do an experiment. I was confronted by two of them they were very surprised that I hadn't ever done an experiment before. I guess they had just assumed that I had done experiments in the past, but they were quite shocked. And so before I knew it, I had donned a lab coat and I was doing an experiment. I was doing my own project in the lab. I tested for the presence of the SRY region, the sex-determining region on the Y chromosome. And the postdoc in the lab actually decided to use my PCR results as the ideal PCR result as an example in his classroom lectures. And I assisted in other laboratory tests too, so anything from just kind of the mundane things of making ethidium bromide agarose gels to whatever else was simple that I could help out with. And really, this was another kind of step in moving towards that, stepping into each other's worlds. The laboratory members genuinely appreciated that I was willing to do the same things that they do on a daily basis. Because before, I would sit there, I'd watch them, but could I really empathize? Could I really imagine myself in their shoes? And at this point, when I started kind of engaging in kind of the materiality of the laboratory, I could start that process of being able to empathize. And there are some benefits to that, including, a greater legitimacy, respect, the sense of being a team. We all do the same thing. We step into each other's worlds, and a new interactional competence that I wouldn't have had if I hadn't had that material experience as well. And so here are just some examples of me pipetting some PCR product into the gel. And this is an example of a gel I made, and it became known by the laboratory as the big fat gel. It was kind of an abnormal one, but they ended up using it and it had some really crisp, clean results. So those are just some pictures. So, throughout the process of these 3 months, there was kind of this iterative back and forth, us stepping in and out of each other's comfort zones. And so after I got back from a workshop in Norway, actually a STIR workshop where the topic was responsible innovation, I was asked to give a lab talk to talk about the workshop and what I learned, because typically, after someone goes to a conference, they'll kind of give a spiel to the lab, what they learned, the types of people that they talk to. So as a part of this group, I was asked to give a lab talk. And so I focus on responsible innovation because that's what we talked about at our workshop. And I wanted to ask the laboratory members themselves what they thought responsible innovation was. And in so doing, I brought up their concerns, and I really asked them to step out of their comfort zone. And ultimately, in the conversations of what does it mean for this laboratory to engage in responsible innovation, folks had lots of different ideas. And the idea of a patient engagement newsletter was actually brought up within that conversation, within that lab talk, which was more of a lab dialogue than me just talking at them. And Courtney was actually out for that lab talk. She was out of the lab, but I brought up something that she kind of considered was, an act in responsible innovation from her perspective, which was patient engagement. And so I just presented that to the lab. Well, I know Courtney's not here, but I know that one of the things that she really cares about is patient engagement. She sees a lab down the hall doing a lot of patient outreach, and this particular laboratory gets a lot of placenta samples. So, what do you guys do in terms of patient engagement? And at the time, not really much at all. But the PI got really excited and ran back to her office to grab, 4 minutes, to grab an example of a newsletter. And she was like, yeah, I've wanted to do this for the last 5 years. I really want to do a patient engagement newsletter to get people involved in the process of our research and to get them, to let them know what they're doing. They're giving this sample, they're giving part of their body. So I want to bring them into that conversation. So that lab talk was kind of midway through, 3/4 through the engagement experience. And I didn't really hear much about it until the very last lab meeting when the PI basically asked the researchers in the room to provide lay summaries for the first patient engagement newsletter. And she said, it'll be great for people to be involved in that process and to know the progress of it. And here's just the quote from Courtney's initial interview when I asked her, what is responsible innovation to you? And that's when she cited the laboratory down the hall that was doing a lot of patient engagement efforts. So that was, I just fed it back into the group. So just some concluding thoughts. I want to just talk a little bit about the laboratory as being a potential site for opening up those contracts that I referenced earlier in the talk. We can treat the laboratory as a site for opening up socio-technical contracts. It's possible and it has value in terms of discursive, in terms of translating the language between the social scientists and the natural scientists, learning in a different way than you would in the classroom. And you can take the example of the SNP as one example of that. Material, in terms of me actually engaging as a participant in the laboratory. And I took those skills and the knowledge that I gained in Courtney's laboratory, and actually when I went to my second site in Oxford, I was able to actually engage in daily tasks. From day one, I basically started pipetting and helping the researchers in that way. So that was kind of like a new level of engagement, me actually day-to-day engaging with the researchers in Oxford, helping them with their research as they dialogued with me about their concerns and whatnot about their research. It has value in terms of laboratory outreach and policy. The lab thought that it was valuable to reach out to people outside the lab in terms of this newsletter. And then finally, it also has value in integration beyond the lab. So I was able to take the knowledge that I gained and the contacts that the laboratory provided me with and start engaging with clinicians, policymakers, plaintiffs from Canadian Supreme Court cases in a way that I wouldn't have otherwise because I had this new experience, this boots on the ground experience. So that's essentially it in terms of my talk, but I just want to take a couple of minutes really quickly to engage with Courtney on just kind of like some really broad questions and issues in terms of collaboration. And just kind of my first question is just, what were some initial hesitations or concerns that you might have had as a researcher in a lab with a embedded social scientist kind of coming in?
So Wendy first proposed this idea to us, and I think the initial reservations may have been that it was really hard to conceptualize what would come out of a study like this. And when we were thinking of, well, what would these possible outcomes be and what would these observations result in, it was difficult for us to imagine like a study structured like that. Specifically, I guess we were talking before today, and when we engage in an experiment, we have a very set hypothesis, and we already have predicted what are the possible outcomes of a given experiment. And so this was quite different in that the outcomes of this study were unknown. And so you were coming into the laboratory, and you had explained your project to us, but we weren't quite sure of what the end product would look like.
And then what about, so you were one of the most receptive folks in the laboratory initially to this collaboration. So what do you think it is about your background that makes you more or less, in general, responsive to collaboration?
I think mentorship is really important. Wendy is very encouraging of collaboration with other labs, and was very interested when you first emailed her. And I think as a PI, having that interest in being involved in other people's projects and in other disciplines, it really encourages the students to be open to such collaborations as well. And for me specifically, I'm really interested in teaching and mentoring other students, and so I also was excited by this idea because I really like bringing people in to work with me and engaging in that social aspect of science rather than just the bench work.
And then finally, what do you think makes for a successful collaboration?
I think open dialogue is really important. Discussing on a continual basis how you think the collaboration is working and what can be provided to the relationship to make it better, and what both parties are getting out of it is actually something valuable that they both appreciate.
Thank you. Thanks, everyone. Sorry if we were running a little late.
So I guess we're going to take some questions now. I'd just like to take a moment to thank Eric very much for inviting me to this event. It's, as you know, Genome Canada has been, I guess, experimenting with integrated social science and humanities research with genomics, of course, for over a decade. We have some, I think, great examples of co-production of research findings, research projects with social science scientists and scientists. What we don't have are very many examples of this type of social scientists living in the labs with the scientists. We have one or two examples, but not very many. And so I'm absolutely fascinated by this work, and so very happy to be here. So thank you very much, Eric, for inviting me. So we should open this paper up for discussion. Who's going to be first? Don't be shy. So while you're thinking, sorry.
You mentioned the gender balance.
Hi, I'm Stephen Dietz. I'm from CSIS. You mentioned the gender balance of how many women and men were in there. Was there any difference in receptivity to your work or any kind of dynamic going on with that?
I think in general, based on gender, there wasn't a difference in receptivity, but I just found it interesting that here I am in a reproductive genetics laboratory, and 6 of the 9 people are female, and so we had some interesting discussions on just kind of infertility and the cutoff of when you should start having babies and stuff like that, and it's tied to the research itself, but the fact that the majority are women, and not only are they doing research on this stuff, but it's also affecting them, in their daily lives as well. I thought that was interesting. So yeah, kind of a different conversational dialogue that we were able to have. I don't know, do you have any thoughts on that? You guys are really open about just kind of like talking about that and talking about fertility and...
No, I guess not really, except that medical genetics seems to be dominated by women largely. So quite often our lab is all female, and we have about one new male student every year or two. So yeah, I'm not sure why that is.
Are they afraid of you?
Thank you for the interesting presentation. My name is René van Schomberg. I work for the European Commission. Just listening to this whole idea on which I'm also fascinated by, sending social scientists to a research lab, is that the language used by those social scientists representing their work sounds very much like that you are going to study an exotic type of people. It reminded me very strongly of a course which I did in the end 1970s in Holland, where some of the social sciences still had some echo of neo-colonial thought. It was called a course on non-Western sociology. And at that time, there were still anthropologists sent to so-called exotic people with the purpose not to interact with them, because you should only look to them, because otherwise you would change their behavior and you would not know what they were actually doing. And this was actually repeated, I think in the 80s also in science studies, where they sent anthropologists to research labs, not to talk to them, but to observe what they were doing. Now, obviously, we are in a new phase. We actually talk now to them, and we send them social scientists. Maybe the next phase is that we use a psychoanalyst, because Eric Visser said they make decisions from which they are not aware, and this sounds, it is almost psychoanalytical language, but we are not there yet. But of course now the crucial difference is that we don't send social scientists to natural scientists to understand them better, like we do with in the past with so-called exotic people. But we try to identify certain consequences of their work. And then, of course, the question is, what makes you think that a social scientist is in a better position than, let's say, a reflexive, embedded natural scientist, if we would send an alternative person to that, to identify those consequences? Just to make the argument go into another direction, if I just think about the Nobel Prize winner Francis Crick, who led to the discovery of the DNA structure, he hardly did any laboratory research himself. He always went to a research laboratory and he exactly put the same questions as you did. What are you doing? Why are you doing this? This did not lead to the identification of consequence. No, this led to the discovery of the DNA model. And this actually reminded me also from you again, because it seems that the natural scientists try to turn you into a natural scientist. So maybe if you would have done longer, it would have led to some type of new discovery rather than to your original purpose of identifying particular consequences of research of natural science. It seems to me that there is an asymmetry in your assumption that a social scientist would know better than a natural scientist does. And I very much doubt this assumption.
Oh, yeah. I think that the important thing, the important aspect of STIR is those questions. Like you said, the questions that Crick asked, or, the questions that, Eric described, like, what are you doing? Why are you doing it? Someone who has a different perspective. And with STIR, we have people from so many different disciplines that that my perspective as a political scientist might be very different from Don's perspective and from his discipline. So even within the STIR project itself, we're coming from so many different angles that it's hard to say that and I would never want to say that I, as a social scientist, know what's better, because really, within this project, it's all about the feeding back. And, if someone can give good feedback and just kind of, dialogue, then I don't see why they need to be a political scientist or anything else. It's really about the dialogue and the nature of it and the engagement, and just bringing different perspectives to bear, just a fresh set of eyes. But that's definitely something that, I'd like to think about more. But you also talked about the, they were converting me into a natural scientist. And that was something that, originally when I put this together, I talked about my fear of going native. And basically, that was one of my initial hesitations, which is why I think it took, a month and a half, 2 months to actually get to that point where, I was, putting on a lab coat and, pipetting, because I had these initial reservations about stepping too far into their world because of, the background and, coming from a social science perspective. I don't want to go native because, that's going to mar the purity of the research, when really it wasn't until, I was like, okay, well, self-consciously, I'm just going to do it. I'm going to go native. I'm going to do this experiment. I'm going to do this project and see what comes out of it. I'm aware at the same time that I'm kind of stepping farther into these shoes. But, it took about a month and a half to kind of get over that fear of kind of going native, if that's what you want to call it.
I think we have a few questions, so maybe we can take a few of the questions and then answer. I have one for you, too. You started with this quote of, talking about renegotiate the social contracts. And I was wondering to what extent your experience actually led you to do that, or just much more actually to modulate some of the practices, which I would say maybe it's not the same. Renegotiating the contract would mean going far upstream and work on the co-production of research questions and question the status quo much more than just modulating practices. So that's one question. I think Dan has one, and Dave.
So really quickly, I see kind of like this idea of the contract, which I'm still kind of grappling with, as, it's a very kind of new concept to me, but I really like it because it helps me kind of engage in this a little bit better. But yeah, I mean, in terms of thinking about the terms of the contract and, who's writing the terms, well, they're being written at multiple levels, at, multiple places and kind of society and institutions and on individual levels. And the laboratory is one place where that can happen. But like you said, the upstream and the downstream. So it's happening at multiple places. But I think STIR is nice because it shows that, at least in my case, you can actually talk about the terms of that contract and, renegotiate them at the level of the laboratory. So, but it's really a new concept that I'm still kind of grappling with and making my way through at the same time. So I think kind of this empirical stuff is helping me think about it conceptually as well. So it's kind of an ongoing effort.
Yeah.
Okay. Very brief response to Renee, and then a question to Courtney.
Could you introduce yourself?
Oh, sorry. I'm Daan Schubius from the Netherlands. The response I have to Renee is I don't think the STIR scientists claim to know better than the natural scientist. I think the idea is we've got certain types of knowledge, so do people in the lab. What happens if we mix those types of knowledge, and could that provide a response to the kinds of policy mandates that are now emerging in the European Commission and also the example that Eric gave. So that was my brief response. The question to Courtney in that respect, I really liked your response to the first question. You said that it was difficult for you to imagine what the outcomes would be of this experiment. And I was wondering if you could expand a little on why that would be a hesitation or a concern. I mean, were you afraid that nothing was going to come out of it, or were you afraid that kind of sensitive data would come out, or could you go a little bit deeper into your hesitation there?
Yeah, I guess it was maybe the laboratory as a whole feeling perhaps vulnerable to having an external person come and sit and observe, and whether these were ethical implications, or how the lab dynamics interacted. I think it's difficult to pinpoint exactly because we didn't entirely understand what was being studied, whether it was us or whether it was the choices we were making and the ethical implications of those on patients. And I think our laboratory has very strong safety and ethical practices. So I think in that respect we felt comfortable having Shannon come in, but more perhaps as like what exactly is being observed and how would we be painted in the overall outcome, whether it would be a positive light or a negative light.
Mm-hmm. And just kind of some of the initial comments of like the PI, she'd just be in the laboratory, and I think one of her fellow colleagues was in the lab, and she said, "Oh yeah, so we have a visitor," and the visiting colleague said, "Oh well, what does she do?" And the PI said, "Well, I'm not sure if she's trying to psychoanalyze us or if she's an embedded journalist and she's trying to dig something up on us." But so there was a lot of uncertainty in that regard. But through human relations and just kind of engaging with each other that way, I think we made it through and had a really positive experience.
I think we've got time for one more question.
Dave Gustin, Director for the Center for Nano and Society at ASU. And I want to question you guys again sort of through Renee's comment as well, but the part about is this something that anybody can do, that the protocol is essentially independent of the person who is representing the protocol in the laboratory? Because one of the senses that I have is that it might be difficult, not necessarily from the person who's applying the protocol, but maybe from the perspective of the people in the laboratory, that might be difficult if that person were, for example, a natural scientist, because the natural scientist might not, in the presence of the rest of the natural scientists, might not have the discipline of the ignorance that the social scientist has. Mm-hmm. In essence, that the dynamic would not necessarily be one where the social scientist has the sort of enforced learning that needs to go on, and through that enforced learning, it makes it potentially easier for the natural scientist or engineer in the laboratory to learn something back. Mm-hmm. That the initial engagement might in fact be one of either, on the one hand, a more traditional, if there is such a thing, more traditional interdisciplinary engagement across the sciences, or something perhaps a little bit more challenging about my worldview or your worldview. Mm-hmm. I'm wondering if either of you, and particularly Courtney, have a perspective on that.
I think I agree with you. Having Shannon come in and starting from scratch, essentially, with knowledge in genetics, it sought us to bring her in much more quickly because there was so much to engage her in. So whether it was teaching her like just basic lab experiments, to explaining our project from like a basic lay summary to more detail as we moved along. We had our weekly meetings, and initially they started out where I kind of tried to explain a whole overview of the general idea of my project, and then we got more and more detailed as the weeks went on. And I think having Shannon's different perspective really added a different dynamic to the lab. In the time that she was there, we discussed, like our lab meetings had much more depth, I would say, like discussing responsible innovation and these types of ethical discussions came up much more, I would say, when you were sitting in on our lab meetings, and I found this like very engaging, and I really enjoyed having the time in the lab.
So, I mean, just finishing off, if we put back ourselves a few decades, what would have been the situation where the chemists started talking to the biologists and vice versa? Is this any different? Both disciplines were quite capable of speaking gobbledygook to each other. And I'm sure that the purists in the chemistry or physics department of university thought they were being polluted with these crazy artists coming from the biology scene. So I think it's just a perspective.
Mm-hmm.
Let's move on to nanotechnology. Thank you very much,
you.
Courtney and Shannon, for that. So now it's Bastien Murat and Troy Ben who are going to talk to us about nanotechnology. Very welcome. I'm Troy. How are you, Troy? Bastien, how are you? Vous êtes français? Vous êtes français? Oui, très bien.
Oh, thank you, Shannon. Thank you, Courtney. Thank you, everybody. So we are going to present our interaction, especially one of our dialogue. But first, I want to present my study in this laboratory. So it was an environmental engineering laboratory in Tempe, and I had 2 high interaction participants. I mean by high interaction, 2 interviews a week, and I had 3 low interaction participants, so 1 interview every second week. And at first, Troy was a low interaction participant, but it moved to a high interaction mode. So, but I will explain it after how dialogue. So we will reenact a dialogue that we had during this study in Tempe. But I'll let Troy explain us a bit more.
Yeah. So I'm Troy Ben, and at the time that Bastien approached our lab with this collaboration, I was working in an environmental engineering lab concerned with monitoring the environmental transport of nanomaterials. So we'd go out and buy consumer products that had nanomaterials in them and figure out how many of those nanomaterials would be released into wastewater streams. And so that was kind of the focus of our group. So, yeah, we'll just kind of pick up the dialogue where we started and where Bastien comes into the lab. And so, Bastien, thanks for coming to the lab. And you can see here on our lab bench, we're looking at the transport of fullerenes into the environment. And so fullerenes are used in cosmetic creams. And so we have this idea that you put cosmetic creams that have fullerenes all over your face and then take a shower, then you're washing these fullerenes off into wastewater streams, and then wastewater's treated and back out into the environment. So we have a lot of fullerene materials here, and we have to make up these solutions. We have to put the fullerenes in water, only they're not very water soluble, so we end up having a lot of waste materials. So we have paper towels and laboratory gloves, plastic syringes, pipette tips that are all covered in fullerenes. And so we don't really know what to do with all these wastes. It's just carbon, and we're all made of carbon, and there's carbon soot everywhere, so it's probably not that big a deal, right? So maybe we can just throw this stuff into the municipal trash. That'd be the easiest thing to do. It'd be the quickest way for me to keep going on with my work. Just throw the stuff in the municipal trash. But we also realize, some people kind of like to keep an eye on what laboratories do, and so we haven't made a decision yet. We just contain all this stuff here on our lab bench, and you can see it's starting to pile up, and it's kind of a mess. So we could treat it as hazardous waste as well. So this is kind of a problem we've been dealing with.
Okay, but why don't you put this solid waste in hazardous waste treatment like you do with liquid nano wastes?
Yeah, so that's the other thing we could do. We could treat it as hazardous waste, but if you step back and look at the big picture of our lab, we're trying to ultimately protect the environment. Is, the grand scheme. So if the fullerenes don't turn out to be that big of an environmental issue, and we spend more energy with the hazardous waste treatment, which has a higher carbon footprint, well, now we're actually doing the environment harm because we're treating fullerenes to a degree that we should.
Can you explain why this hazardous waste treatment has a bigger footprint than the municipal waste treatment?
Yeah, well, hazardous waste, there's more containment, so there's more energy put in. to keep these materials isolated, and then you have to have specially trained hazardous waste collectors, people come and pick up these materials and take them to a specialized facility that needs to be certified as a hazardous waste treatment facility. But then ultimately the waste will probably be incinerated. And even in municipal treatment systems, I mean, fullerenes could be taken to an incinerator. And so in which case the fullerenes are, you know, combusted into carbon dioxide. And so both end treatments for these fullerenes have the same effect, which is they're turned into CO2.
Yeah, but that's your that's your assumption that the municipal waste treatment will burn it and transform it in carbon dioxide or protect it with a film for the landfilling. But what? How do you deal the problem of environmental protection from contact with nanoparticles?
Well, that's what we're saying is, that's what we can't figure out is that, you know, if we treat it as municipal waste, are those fullerenes more probable to be released into the environment than if we treat it as hazardous waste? And we just don't have any information that says one treatment method is better than the other. So if that's the case, then it's easier for us just to use the municipal disposal and keep going about our business.
Yeah, but there is a current state of knowledge about nanoparticles that is quite uncertain. For example, the OECD says that there are no blanket statements about toxicity of nano-sized materials, and there are many other statements. I won't quote them all. In the state of uncertainties, don't you think it would be safer? And one of the other participants say that it will be a safety principle to contain it or to treat it as hazardous waste treatment. Yeah, I want you to maybe think about the precautionary principle that might advise you to treat it as a hazardous waste, given the current state of knowledge that is quite bad.
Yeah. We hear the argument of the precautionary principle being used a lot, but we can't seem to put it into practice because it doesn't make any sense to us, because we don't know what we're trying to protect. If we're trying to protect the environment, then the best way to do that might actually be to use the municipal waste treatment for the fullerenes. So there's so many questions that we have about it, is, you know, what carbon footprint is bigger. I mean, and that would take a whole, you know, at least one more PhD study to figure out the data to give us some kind of idea of how to do this decision. So I think we might want to break, this is where we kind of break out our dialogue, and then we stop and think, well, is this whole conversation a waste of time? Because in the end, I still don't have a decision of whether I should use just the trash can or some hazardous waste treatment method. So
yeah, and I wanted to show you that other example of cities or maybe institutions like the British Standards Institution or the City of Berkeley made some laws to treat these nanoparticles. They made a special regulation for these nanoparticles to be treated as hazardous wastes. And why wouldn't you just follow them? And if you do so, you don't waste your time. You just follow.
Yeah, there are institutions and communities that are moving towards instituting guidelines for nano waste disposal, but we don't necessarily know what that's based on. If it's based on, you know, a good public image, then that's one thing, and that would definitely be one reason to choose maybe hazardous waste disposal. But if it's based on protecting the environment and, you know, using hazardous waste disposal of fullerenes is actually a higher carbon footprint for a material that might not have that big of an environmental risk, then we don't really know what decision makes the best sense.
Okay, so finally, I just want to provoke you and say maybe you are a kind of activist and that you appropriate the nature as it is yours. And I give you the example of Grenoble, where I come from in France. Activists against nanotechnologies wrote on a mountain fortress, no nano in big letters, so all the city can see no nano. Yeah, 500,000 people can see no nano in the city. And maybe you are an activist as well, because you appropriate the nature and you just show your opinion and you just act in a way that the public doesn't express itself. So, yeah, I just wanted you to think about it. So that was a dialogue that we had during at the end of my study, and so with Troy we moved from low interaction to high interaction because first because of time issues, and then there were a kind of breakthrough moment with Troy when he started to talk to me about this containment dilemma, and I was advised by some people at CNS like Dave Guston and Eric Fisher to maybe look more into this direction, and I think it was a good help for me as I was still a graduate student, so I needed some advice, and so that was a breakthrough moment for our collaboration. And Troy, did you see any barriers to our collaboration and any breakthrough moment?
Yeah, I'd agree with some of the barriers that were brought up with the previous presentation. Is that it's a little bit discomforting anytime you let somebody from outside your lab come in to watch over your shoulder as you work, and whether that be a journalist or even a lab safety coordinator. You never really want to be working and have a safety coordinator tell you you're doing something unsafe, because it makes you feel pretty uncomfortable. And so it's the same thing with a social scientist coming into your lab. You're not quite sure how everything's going to shape out, but it's a small discomfort, and the intellectual discussions about what it is that you're doing usually overcomes that initial discomfort. And then the other barrier would probably be time, because if you're doing this other collaboration, you're taking away from what the main focus of your research could be. So there's academia being a pretty scheduled. Your research is usually pretty scheduled to its fullest, and so you're always scratching for more time and how to get things done. And so it's an issue with, if you're doing another collaboration, are you really going to get a publication out of it? Are you going to do a presentation out of it? Is it going to advance your career? And for some people that's important, and for others the collaboration is enough just to kind of experience a new research theme. So that's something to think about.
You finally think it is a real waste of time?
No, it's not. It's not a waste of time. Just because, for me, I enjoy just talking about some kind of complex problem like that. And if you don't come to an answer, then it's all right. Ultimately, it didn't help us in the lab for making a decision on what to do. But it does help us consider what people outside the lab are concerned about with our laboratory practices. And so you get that perspective of, from the nanotech industry, there's a whole, consumer products sector that's concerned about what regulations are going to be forthcoming for nanotech, and you can understand that they're having the same dilemmas, which is, what do we do with this stuff? Won't somebody please just come and tell us what to do, and then we can just do it, and then it'd be fine. But nobody quite has the answers yet. So the next best thing is for us to be talking about it and see what our alternatives are.
Okay. Thank you.
Thanks very much. Thanks. So we have time for discussion and questions.
Farzad Mahoutian with NYU, previously with ASU, and I had heard this presentation previously, like maybe a year ago, I forget exactly when, but there was one point, hearing it again, that I was reminded of something I want to ask you about. It seemed like in the previous one we were talking about quite a bit especially afterwards, regarding the scientist learning something, or the lab researcher learning something from the social scientist interaction. If I remember right, in the previous presentation, there was a long discussion about Bastian revising the precautionary principle as a sort of in response to Troy's calling it irrelevant and saying how it didn't apply. So in a sense, there was a transfer of a reconsideration of how ethics would apply in this case because of how it went in the lab. I don't remember if I have it all right, but could you?
Yeah, I explained that during this presentation. I explained that, and it's maybe due to my background as I'm French and in political sciences studies in France. We are really familiar with the precautionary principle notion, and it's really something that comes back often, and it's in our constitution. So it's something that we cared about and that we kind of defend, even though we try to be objective. But so I try to introduce this concept to Troy, and I saw reflexivity with this notion, and for example, I learned from him that hazardous waste treatment, even if it protects the environment from nanoparticles, it might not be the best solution if nanoparticles don't damage the environment. But as I said, we don't know. There's a bad state of knowledge about it, and yeah, he kind of taught me that hazardous waste treatment is not so environmental friendly. So precautionary principle was it was a kind of reflexive concept for us.
Rup Mahajan from Virginia Tech. I have two axioms, and I'll state those, and then I'll ask you a question. I normally say that buds of creativity bloom at the intersections. Okay? And the second one is that innovation is directly proportional to the separation between the two intersecting disciplines. Okay? So now the question for you. When you were talking about the fullerenes, whether to send them to the municipal waste or as a hazardous waste. So did the innovation come into being? Hey, how can we avoid both of these problems and come up with an innovative solution?
No, we hadn't got there. I mean, because the way we were thinking about it is, here's waste. We just want to get it out of here, and we have furnaces in the lab where we can do small experiments where we can burn the fullerenes off, and so we know at what temperatures they turn into CO2. But that's not it. The furnace wouldn't be a way for us to get rid of all our waste because we have a lot of plastics and other stuff that we can't get rid of. So no, we hadn't quite got to that part of the collaboration.
Yeah. I'll mention later on during my talk that we bring a lot of people together from different disciplines: chemists, philosophers, scientists, and then we ask them the question about disruptive technology. So if you had a few more people in your mix, they might tell you, maybe I want to functionalize these fullerenes, and I have a different way of treating with them. So that would be something to think about.
Yeah, thank you.
Any more questions, discussions, comments? Of course.
This kind of goes back to the other discussion, but it's related here as well. I'm sorry, I forgot your name. Renee, right. Renee brought up, couldn't a natural scientist, a physical scientist, do as well or better in terms of enabling innovation to happen in the lab than a social scientist, or as Dave said, couldn't it be anybody? And this made me think of your progression from anthropologist to social scientist to eventually psychoanalyst. Perhaps there's another route out of that. If natural scientists or physical scientists were educated differently with respect to this kind of self-reflexivity and integrative understanding of social impact, societal impact, then they wouldn't have to be psychoanalysts necessarily, but they would be in a position to do certain kinds of introduce certain kinds of innovation in the lab. On the other hand, the kind of feedback going to the social scientists that we saw here regarding sort of, in this case, Troy sort of was inducing self-reflection in the social scientist, who was there to induce self-reflection in the scientist. Because here we had this interesting discussion about how the precautionary principle should be revised and understood in its application to special different circumstances that we have here. So it kind of, in both ways, one, the education of scientists should be different, but that wouldn't totally replace the injection of, not the right word, injection of social scientists into the lab.
Renee, did you want to?
Yes. I think if I would rephrase my point a little bit differently, it's, I mean, the crucial question which comes to my mind is, with what purpose this individual, whatever it will be, a natural or social scientist, is sent to this research lab. If it's about trying to understand research practice better, then probably this was not a good choice. But my understanding of Eric Visser's work and others is actually this is not what it's about. We don't try to understand these scientists better. We try to be reflexes, of course, on the mid and long-term consequences of their work. Now, but my point actually is that if we want to, we have a common understanding of what we try to achieve. However, if you look to what you with what means you want to achieve this end, it might be actually better try to understand these research practices better. Because the question is on a sort of pre-normative level. You want to know about the consequences of, let's say, knowledge use, which ultimately goes to particular technological developments which are very difficult to predict. Everybody knows that hardly anything can be predicted on the mid-long term. So this is what we try to get grip on. So my point is actually, in order to get there, I think we need a better understanding of this pre-normative level, how knowledge is used in research and how it is used in neighboring research fields, from which the initial scientist has no idea what happens with the knowledge initially produced. Like we know in science is basically an area where you have an ongoing fragmentation of the scientific disciplines in smaller areas. Scientists know ever more about less. And this makes it so difficult to go the other way around. What is the consequences of knowledge production in these tiny fields, so to speak, up to the bigger level? So I think the basic question is the choice on sending somebody there with what capacity you want to equip this person. And it seems to me that it's not about educating the other person. I mean, if that would be the purpose, then you are actually too late in the chain, I agree. But the purpose is trying to understand it better with a view on what is going to happen with this knowledge being produced and can be utilized by anybody else. And this seems not to be captured by this exercise of sending social scientists. Of course, this I don't want to say that it is then useless. It serves all kinds of other interesting purposes. But on this point, I think it needs another dimension.
I was just going to say, I'm a molecular biologist, and I had no idea what we were talking about when this first started, but I've slowly become more and more interested in what we're talking about. And to sort of the point that they were asking, in regard to who do you send to the scientist or to the natural scientist. I think it depends on what you want to get out of it, right? Because an apple tree to a farmer is food, and yet to a physicist it's gravity, you know? So if you want a political science or social science perspective, then a social scientist is a great person to send. When biology wanted to become more quantitative, they teamed up with mathematicians. So I think instead of the trap that I think a scientist is easy to fall into in this case is to assume that you're talking about making their science more relevant to society, when maybe that's a big umbrella to use, but specifically you want to open doors between disciplines. I think sort of pitching it to me in that light becomes much more engaging and interesting to me. Science right now, especially molecular biology, is looking at any way that they can to team up with physicists, computational biologists, mathematicians, and this sort of people to broaden the swath of biology. And I think this program would be very attractive to them put in that sort of statement.
You wanted to make a comment yourself, Eric? Just briefly. Yeah.
No, that I'm quite that tall.
Yeah, so just maybe a couple brief comments. One is that as I got the story, Bastien and Troy had this discussion, and I won't say what the lab was doing before the discussion, but then the stuff started piling up on the desk after the discussion, right? Because there was a dilemma that was sort of latent, but it hadn't been considered. Now, you could make a powerful argument that that wasn't a help to the laboratory, that slowed things down. It was more than a waste of time. It was actually counterproductive. But at the same time, I think, you know, these guys were sending me emails. They'd be digging around for policies, looking for a policy. And, you know, they finally got something at the OECD level that said, basically, we don't know what's going on, but we know it's piling up somewhere, and at some point it's going to pop out, and we'll find out about it. So, you know, another way to think about what this interdisciplinary collaboration did was it opened up doors not just between disciplines and between thinking, but of different sectors of innovation. And it raises questions about what responsible innovation is. Roop's got a brilliant solution at the lab level, or he's got a brilliant enabling question at the lab level that can spark innovation there. These guys were also, they're writing an op-ed, and their take on it is that this is the limit of midstream modulation, right? So if you don't follow Roop's innovative approach, you say, okay, we can't do anything, we need to now push back, and it becomes a problem for the whole system. So it catalyzes a dialogue. So I just wanted to make those 2 points.
One last one, and then we have to break.
So I believe the gentleman's name is Rene. What he said, of course, is true, but I don't believe it's inevitable. He talked about the fragmentation of science into ever smaller knowledge blocks. This, I think, is a function of the structure we impose on science. And one reason, as a physical scientist, I wanted to become involved with this group is because it seems to me that some very, very simple policy changes on which actually everybody agrees but no one will act in typical American political style would make huge differences. I happen to work in an interdisciplinary institute where I've had the pleasure of backtracking from my disciplinary silo, and I've seen the effect on my graduate students who are much better educated than I was. The National Science Foundation is just an atrocity for silos, and changes at the NSF to encourage greater integrative research and behavior amongst scientists would be a very, very simple thing to implement. And I sort of hoped when I got involved with this group, somehow because they were called political scientists, it would feed through to politicians and we would see revolutions in Washington. So if I can just urge this group to come up, formulate and lobby for policies that change the way we organize science, because we respond to money, incentives, and political structures as human beings. And these are not being changed. We're just locked into this traditional siloed way of doing things. Folks, we can change this. And I would actually like to see people who understand the political system better than physical scientists doing something to change it.
And with that, I think we should take a break. Thank you very much indeed. Thank you.